All right. Well, hello everyone. As was mentioned, my name is Jaron. There we go. Hi, my name is Jaron. I'm the CTO of DDV Tech. We built MistServer. So if you hear DDV Tech or MistServer, that's because once the company, once the product, we're right over there. And, well, of course, we fix all OTT problems. But you might not be using MistServer or not wanting to use MistServer. So you might want to know how we solve these problems. Well, some of the common ones, at least. So I present OTT demystified, like how you would solve them if you weren't using us. I'm going to go over a little bit of OTT history, and then I'm going to dive into the common problems of protocol selection, codec selection, segmenting, and scaling. And I'm going to try and not talk as fast, because otherwise this is going to be over in a few minutes, which I'm sure everyone would be happy with, but eh. All right, history-wise. Well, first internet streaming was mostly audio only because of bandwidth concerns, because people were using modems over phone lines, and surprisingly, modems and phone lines, they tend to have enough bandwidth for about a conversation or so. It's like they were designed for it. And then a little bit later, as bandwidth increased, people did what we now call VOD, pre-recorded videos. And back then, it was just they were uploaded to a website. You would download them and play them in a media player, because browsers playing video back then was just, yeah, that was it. That was not something you could take serious. And shortly after, IP cameras appeared, which used the real-time streaming protocol. And most still use real-time streaming protocol to this day, even the very modern ones, because it's a very robust protocol. But that doesn't really work on the rest of the internet. It just works for dedicated applications like that. And then Adobe came with their Flash player, and suddenly we had really cool vector animation online and progressive streaming support. And later they also added RTMP, which is still sort of the standard for user contribution. And now we've arrived roughly today, and we have HTML5, which has proper media support on the internet, finally. And, well, Flash went away in a flash. And, yeah, that's where we are now. So that's what we call OTT, this, streaming over the internet instead of over traditional broadcast. Let's go into the problems now. Yeah, what should we do today to do this? So, protocol selection. Protocol selection is mostly about device compatibility, because no matter where you want to stream, there's some target device that you want to have. This could be people's cell phones, it could be set-top boxes, smart TVs. There's always something you want to make sure works, and you can't make everything work. Well, we do our best, but making everything work is infeasible, so you tend to focus on a few target groups of devices that you want to work. And this decision basically boils down to, if you are targeting iOS, you're using HLS or WebRTC for live, because those are the only two that Apple will allow for live on iOS. And for VOD, you tend to do MP4, because that does work and it's a bit easier to work with. Though you could do VOD over HLS or WebRTC if you really wanted to. For most other consumer devices, it's a mixture of protocols that tend to work roughly equally well. There's MP4 and WebM, which is similar to file downloads, except they play directly in browser. There's the fancy new kid on the block, WebRTC, which does low latency specifically. And then there's the segmented protocols, which are these days HLS, Dash, and CMAF, which are roughly equivalent nowadays. For special cases like IP cameras or dedicated devices, set-top boxes, RTSP, RTMP, and TS are still used in combination with the rest. For most people, it tends to come down to using HLS for live and MP4 for VOD, because that's the combination that works on practically everything. But it's not always ideal, because HLS tends to have a lot of latency, and not everything might work well on MP4 because it has a very large header. So it can take a while to download, so you might want to pick a different protocol instead. So that's how you should select your protocol, roughly. Of course, I'm going to do this pretty quickly, because you can't go into all the problems in one go. The next problem is codec selection. Now, codec selection is also largely about device compatibility, because depending on what chipset is in a device, you may or may not have hardware-accelerated decoding support. Now, hardware-accelerated decoding support is important, because if it's not there, you can literally feel the phone in your hand burning up, because it's trying to decode something that it doesn't know how to do with a chip. It's doing it in software, and software requires CPU, which requires power, which burns up your battery. So if you're doing anything mobile, you need to have hardware acceleration. And hardware acceleration tends to change over time. Now, right now, H.264 is the most widely supported codec. It works on pretty much every consumer device that still works. Like, maybe some people have something really old from 15 years ago that's somehow still functional, then you might have a problem. But I don't think anyone expects modern video to play in devices like that anymore. We also have HEVC, which is like H.265. It's the same codec, it's just a different name for them. It is on newer devices that works great. It gives you better quality per byte of data. The annoying parts are that not all devices have it, just the more modern ones. And the patent pool is a nightmare. H.264 also has a patent pool, but it's pretty clear-cut how you pay royalties. With HEVC, no one even really knows who you should be paying and how much. And so some people tend to stand away from it, especially because not all devices are compatible. For the future, I'm kind of hoping that AV1 is going to be the next big thing, because there's so many companies backing it. There's hardware vendors doing it. I'm guessing that within the next few years, we will see support for this on all modern devices. And since there are theoretically no patent pools for this, it would also be free to use. So I think if all devices start adding this and it's free to use as well, it would be pretty much a no-brainer to switch to that in the future. So prepare for AV1 and use H.264 today. And if you really care about limiting bandwidth as much as you can while keeping high quality, you might want to think about HEVC. All right. Next problem, segmenting. This is specific to segmented protocols, so HLS-CMAF, also HSS, but that's not very popular anymore since it's mostly CMAF with a different name. These protocols work with small segments of data, so basically smaller downloads of a couple seconds or sometimes milliseconds or minutes of media data that are then played one after another. And the idea is that you can keep the old method of downloading files and sending files over regular plain old servers without having to put anything specific for media in there. And you can still do live streams because you have tiny little pieces that you can keep adding to the stream and then removing the old ones. Now, segmenting is how long those segments are. So do you make them 1 second, half a second, a minute? And the things that are affected by segmenting are startup time, latency, and stability. Now, when it comes to startup time, smaller segments load faster because they take shorter to download, which means that the startup time is reduced. So if you want low startup time, make small segments. The same goes for latency. Because there are smaller segments, the buffer on the client side will be smaller, and then latency is lower as well. This is the technique that everyone is using to do low latency HLS over the last few years. There's new stuff coming out soon, but this is the current technology. Basically, they make the segments really, really small, and then the latency is low. And they call it all kinds of fancy names, but that's what they're doing underneath. And then the big downside to small segments is stability, because longer segments are much more stable and have less overhead. So you're wasting more bandwidth by doing small segments, and you're decreasing your stability by doing small segments. Because if there's something wrong with the connection, and if even one segment is missing, your stream starts buffering or stalling, and nobody wants that. So it's a constant battle between do you make them long or short? And it depends on if you care more about the latency startup time or more about the stability. And the annoying part is that most people want all three. And well, you sadly can't have all three. So the key thing is knowing your market, where your priorities are. And if you're doing something where latency is a big thing and startup time is a big thing, like if you're in the gambling industry or something, you want to do small segments or maybe not even go with segments at all, but use like a real-time streaming protocol like WebRTC or RTSP. But if you're more traditional and sending out content, then it's a good idea to make longer segments. I mean, it will take slightly longer to start up, but it will play much more smoothly, and it will use less bandwidth. So it's all about knowing what you're doing and picking the configuration that goes with that. All right, the final problem is scaling. Now, scaling can mean two different things. It can either mean delivering at scale, so you have lots and lots of viewers or lots of different broadcasts, or even lots of both. Or it can mean that you want to scale up and down as demand changes. So maybe you have a platform that has a few people using it at night, and then during daytime the usage explodes and goes way up, and then at night it goes way back down. And it would be a waste to have servers running all night long not doing anything. So you kind of want to turn most of them off, and then you want to boot them back up on the morning, something like that. And there are several approaches to solving the scaling problem. You can solve it by, for example, partially using cloud capacity. So the capacity you always need, you would have that in-house, for example. And then on the peak times, you put some extra cloud capacity in there, which tends to be more expensive. But since it's really easy to turn it on and off, people love adding that for their peak times. You could use a CDN to offload the scaling problem. So you create the content, you send it to a CDN, and now it's their problem. It's not really solving it, it's more moving it to someone else, which is nice because they will solve it for you. Peer-to-peer tends to be a solution. There's a couple companies here that do that. By sending the data between all your different viewers, you don't have to send it all from your own servers. And when you don't have to send it all from your own servers, you can save bandwidth and make scaling slightly easier. The problem is peer-to-peer only really works well if you have a lot of viewers watching the same moment in the same stream. So for stuff like the Olympics or something, this will work great. But if it's like, 2 years ago's episode of some TV show, you're probably not going to have a good time doing this. Of course, there's the traditional adding and removing of servers, which is a pretty obvious way to do things, but it's hard to do logistically because you need to wait to do this. Load balancing, of course, is required for most of these things if you want to do them. So deciding where viewers are going to go, are they going to go to a particular server or not? And you can sort of move them away from servers you want to turn off and then move them towards servers you want to keep on and switch them in and out as needed this way. And of course, there's always just buying more bandwidth for your existing servers or having some kind of deal with your bandwidth provider that lets you use more or less depending on time or day, and combining any of these. There's no real easy answer to this, and it really depends a lot on how your business is structured, so there's no easy answer. Key to doing this properly is having good statistics and metrics on your system. Because if you know what the usage is during a particular time of day, you can prepare for it, and it tends to be a very clear pattern in these things. So if you know what's happening and how much load you're expecting for particular events or times of day, you can kind of anticipate it and make sure that these above things are done in time and not after the fact. All right, so back to us at MistServer, we provide ready-made solutions for all of these problems and many others, so that you don't have to reinvent the wheel yourself, and you can sort of offload some of the thinking and the troubleshooting to us. If you're facing some other problem, we can probably help as well. You can ask questions if you would like to, or of course you can drop by our booth right there, or shoot us an email if you're watching this online, or if you come up with a question later after the show.